All right, welcome to another video. In this video, I'll be looking at the revision question to the last topic, which is the first topic in the chemistry syllabus for JAMB, separation of compound, pure and impure substances. Now, why this is very important is that revising questions like this will help you to clear your doubt, number one. Number two, it also helps you to reinforce those things you have learned. Number three, it also helps you to know those things that will be emphasized, that you should emphasize in your learning. And number four, it helps you to know how the questions are framed in the exam. So putting all of this together, we are going to go through questions from the past questions, about 50 of them, that will cover the entire topic we looked at in the last video. This will help you to be well prepared for the exam. So let's start with the first part, the questions on pure and impure substances, element, compound, and mixture. So this first question says, in an experiment, which of the following observation would suggest a solid is a mixture? So you have all of these options. Which of these options represent a mixture? So the first option says the solid can be ground to a fine powder. The second one says density of the solid is 2.25 gram per dm. The third option says solid begins to melt at this point and then completely melted until 648 Kelvin. And the last option says the solid melt at 300 Kelvin. So how do you know a mixture? Remember, a pure substance has a definite melting point, but a mixture doesn't have a precise melting point, meaning a mixture will melt over a range of temperature. So if the solid begins to melt at 573 Kelvin, but is not completely melted until 648 Kelvin, then it implies that this solid is impure. And the answer to that question would be this, option C. The next question, it says, mixture, which of the following substance is a mixture? This is taken from UME 1987 question 2. How do you know a mixture? Number one way of knowing a mixture is that it doesn't have a chemical formula. The entire mixture doesn't have a chemical formula. The constituent might have, but the mixture itself wouldn't have a chemical formula. All right, so if you look at granulated sugar could be glucose, right? You have seawater, you have sodium chloride, and you have iron filings. For granulated sugar, this is definitely a compound. For seawater, you have sodium chloride in water. That's already a mixture. Iron filing is a singular constituent of iron. You have sodium chloride alone here, which is sodium and chlorine chemically combined. Therefore, when you have sodium chloride in water, as seawater, this is the mixture. So the right answer to this question is option B. Let's go on to the next question. Question number 3. It says, which of the following are mixture? Which of the following are mixture? So you have petroleum, you have rubber latex, you have vulcanizer solution, and you have carbon 2 sulfate. If you look at all of these all of this listed for this question, petroleum is a mixture of different components of crude oil. Rubber latex solution, latex. Number 3, you have vulcanizer solution, and number 4 you have carbon 2 sulfate. Carbon 2 sulfate is this. This is represented with the carbon 2 sulfate. Sorry, this will be carbon 2 sulfate. That's CS. That's CS. Right. So if you look at all of this, only carbon 2 sulfate is a chemical compound. Every other thing is a mixture. So you have 1, 2, 3 as mixture. So the answer to that question will be option A. If you have any question, you can put it in the comment. Let's go on to the next question 4. Now, which of the following is following substances is not a homogeneous mixture? So you have the concept of homogeneous and heterogeneous mixture. Now, when you say mixture is homogeneous, it means that all the particles are very small, and therefore, when they settle under the influence of gravity, I mean, when you subject them to gravity, they do not settle. That's homogeneous because the particles are very fine and well mixed together. But when you have heterogeneous mixture, the particles are not um, very small and mixed together. Therefore, when you subject it to gravity, it begins to settle. You have the larger particles settling at the bottom. Now let's look at our options. You have filtered seawater. The word filtered has changed what you have here. So because you have filtered the seawater, you have taken out the sodium chloride. So you only have the water. Soft drink is a homogeneous mixture. Writing ink is the same thing. The particles are well mixed together. They are small particles. So when you subject to gravity, it will not settle. But look at flood water. If you centrifuge flood water at high speed, you're going to have different particles settling at the bottom. Therefore, if flood water would be heterogeneous, while every other thing else here would be homogeneous. So the right answer to this question would be option C. The next one is question number 5. Which of the following is a mixture? You have sulfur powder, you have browns, you have distilled water, you have ethanol. Distilled water is water in a very pure form, and that this is a compound because you have H2O. Right, for sulfur, sulfur is also an element. For browns, it's a mixture of copper and tin. Copper and tin. And for ethanol, of course, ethanol is an organic compound. It's an organic compound. So the right answer to this question would be browns. This is the only mixture in this question. The next question, 6, is drawn from UME 94. A solid usually melts over a wide range of temperature. Sorry, a pure solid. Remember that pure solid melt at a definite temperature. Definite temperature simply means a narrow range of temperature. So if it's a wide range of temperature, then it means that it's impure. For example, if it melts from, like the first question, 640, let's say from 643 Kelvin to 800 Kelvin, it completes melting at 800, then this is an um, impure solid. So melting over a narrow range of temperature, meaning that you have, let's say, 643 to 643.1 or point 4, point 3. You can see this is not significant. It's a very narrow range. Let's look at option C. It says at a lower temperature than the impure one and at the same temperature as the impure one. So of course, you know, this is ruled out because pure solid and impure solid do not melt at the same temperature. But what does impurity does to melting point? The presence of impurities lower the melting point of a solid, and the impure solid usually, of course, they melt over a wide range of temperature. So the presence of impurity would lower the temperature. So for a pure solid, it will melt at a higher temperature than an impure one. So not a lower temperature, but at a higher temperature. So the answer to this question therefore becomes option B. Let's look at the next question. Question number 8 and 9. Use the graph below to answer questions 8 and 9. So you have this graph here, and the first part of the question says the section PQ indicates that X is a mixture of salt, B, a hydrated salt, C, an ionic salt, and D, a pure compound. First, what is going on in this picture? This is what you have in this graph is the typical cooling curve. So you call this a cooling curve. But in this case, this cooling curve is starting from this point. Remember that for a cooling curve, you are moving from a high temperature to a low temperature over time. So you have this point, you have 0, P, Q, and R. So from O to P, this is the liquid phase. And then at this point, you have your melting point. And at this point, you have, at this point Q to R, you are going to be having your solid. Right. So at this point, P to Q, during melting, you are going to be having liquid, a combination of liquid and solid. But at this point, Q to R, you're going to have just solid only. So here will be liquid only, and here will be solid only. Now, I've mentioned that point P to Q is asking you, the section P to Q indicate that X is a mixture of salt, a pure compound. Now, let us look at what is going on. This is point P to Q is the melting point. It is that at this point, the temperature doesn't change. You can see the temperature remains constant. So meaning that whatever you have as your X is melting at a definite temperature. And one of the criteria for a pure compound is that they melt at a definite temperature. So this compound here is a pure compound. The right answer to that question is D. The right answer to that question is D. Now, let's look at of course, you cannot, there's no way you can tell if the salt is hydrated or ionic from this cooling curve. Of course, the only thing you can tell is if the salt is a mixture of salt. If this melting point is not constant, if you have a melting point that is like this, meaning that it's melting over a range of temperature. So, but if the melting point is constant, then it is a pure compound. Now, another part of the question says the section OP suggests that X is. Now, what's the section OP? Let's go back to that. Section OP is this point here, which is the liquid phase. So, OP is a liquid state. If you can go back to the last video, I treated the cooling curve and the heating curve in that video. That would refresh your memory. So the right answer to this is A. Then we'll move on to the next question, number 9. It says, which of the following compound of aluminium, silicon, oxygen, and hydrogen, which of the following is composed, sorry, of aluminium, silicon, oxygen, and hydrogen? So you have Epsom salt, you have limestone, you have clay, and you have urea. And so the answer to this question is clay. If you look at the formula for clay, that would be that will have aluminium in it, Al2O3.2 silicon oxide, and you have water, 2H2O. So you can see that clay has all of these elements present, oxygen and hydrogen. So the right answer to this question is C. The next question says a pure solvents are obtained by or process. You have extraction, you have evaporation, you have distillation, and you have condensation. Remember that you have combination of solute. We're going to go back to that equation, plus solvent will give us a solution. Remember? Now, for you to get a solvent out of a solution, you have to carry out a distillation. And when you do a distillation, you're going to be obtaining that solvent in its pure form. That's why pure solvents are obtained by this process of distillation. Question number 11. It says the heterogeneous mixture can be defined as any mixture whose composition is uniform. No, this is homogeneous. Whose composition is not uniform? Yes. Formed by solid and liquid, doesn't really matter. Of a solute and a solvent. So the answer is given up itself at option B. Heterogeneous mixtures are defined by their lack of uniformity. Question number 12. In countries where the temperature falls below 273 Kelvin, salt is always sprinkled on icy road in order to. Now, when you sprinkle salt on icy road, it's one method of adding impurity Remember that when you add impurity, impurity would lower impurity would lower the melting point. So it lowers the melting point of ice. That's the whole idea. The right answer to this question then is option A. Every other thing is not correct. So impurity lowers the melting point. Question number 13. The presence of impurity in a substance will cause its melting point to reduce. That's a question repeated in another way. Question number 14. A mixture is different from a compound because A mixture is always homogeneous while a compound is not. A constituent of a compound are chemically bound together while those of mixtures are not. This is true. A mixture can be represented by chemical formula. No. The properties of a compound and those of its individual constituent, while those of mixture differ from its constituent. No. So the answer to this question is option B. With those questions, we've come to the end of pure and impure substances. Now let's go to chemical and physical changes. Questions on chemical and physical changes. Beginning with this question 15, it says the dissolution of common salt in water is a physical change. Why? Because A, the salt can be obtained by crystallization. The salt can be recovered by the evaporation of the water. That's very right. And C, heat is not generated during mixing. D, the solution will not boil at 100 degrees Celsius. Of course, the answer to this question would be option B. Salt can be recovered when you evaporate, when you evaporate them in an evaporating dish. You have, let's say this is your evaporating dish, and you supply heat. So you have heat at this point. So the water will evaporate and you have the salt remaining in the evaporating dish. So in that way you can recover the salt when the water evaporates. So that's the right answer. Now we go on to the next question. Which of the following is an example of a chemical change? So you have dissolution of salt in water, that's a physical change. Rusting of iron, this is a chemical change. Melting of ice, this is a physical change. Separating a mixture by distillation, this is a physical method. So the right answer here would be D. Everything appears simple so far. If you have a good note, then things will appear very simple. So far, everything appears to be very, very simple. Now let's go back to let's continue with question 17. The addition of water to calcium oxide will lead to a physical change, a chemical change, the formation of a mixture, endothermic change. Of course, you know with this kind of question, your answer is between A and B. It's a question that is testing your knowledge on what the physical or chemical change is. But what exactly is happening when you add water to calcium oxide? So when you add water to calcium oxide, you are going to be forming calcium hydroxide. So when you add water to calcium oxide, you're going to be forming calcium hydroxide, and that would be um, a chemical change, right? Because it's a chemical process. Let's look at what the equation would look like. So you have calcium oxide and you add water to that, and you're going to be forming calcium and hydroxide, which will be this OH2, right? So in this case, this of course, calcium oxide is solid, water is liquid, and calcium hydroxide in this case will be solid. This is actually a process called slacking. The process of slacking is when you add water to calcium oxide. This is a purely chemical process. So the right answer would be um, B. Now let's go to the next question. Which of the following is a physical change? Freezing of ice cream is a physical change. Dissolving calcium in water? No, it's not. Burning kerosene, this is a chemical change. This is a chemical change. Exposing white phosphorus to air. Of course, this will also be a chemical change. So the right answer to this question will be freezing of ice cream. Question 19. A chemical reaction is always associated with. A chemical reaction is always associated with A change in the nature of the reactant, the formation of new substances. We stop here. Formation of new substances. That is how you know a reaction is a chemical reaction. You have a new substance that is different from the constituent that form the new substance. So the answer to this is B, without wasting time on the other options. Question number 20. The difference between chemical and physical change is that in a chemical change, heat is supplied, a new substance is formed, oxygen is consumed, a reversible process occurs. You can see again, this is just same as question 19. It is the formation of a new substance that determine if it's a chemical change. So the answer again is B. Now let's look at question 21. Which of the following is a physical change? Again, we know that this is a physical change. Freezing of ice cream. Every other thing here would be a chemical change. And this is a repeated question. Mind you, this is 2009. Now, again, this question was in 2003. So also buttressing the fact that questions are often repeated. And I know that in the next exam again, most of the questions we're treating here would be repeated in the exam over and over again. Now, with that, we've come to the end of physical and chemical change. Now, let us conclude this session by looking at questions on separation processes. Then I'll begin with this question 22. It says a small quantity of solid ammonium chloride was heated gently in a test tube. The solid gradually disappeared to produce a mixture of two gases. Later, a white cloudy deposit was observed on the cooler part of the test tube. The ammonium chloride is said to have undergone a process called A. Distillation, B. Sublimation, C. Precipitation, D. Evaporation, E. Decomposition. Now, the right answer to this question, of course, would be sublimation, when the solid changes directly from solid to gas without going through the liquid state. An example of a compound that does that is ammonium chloride, actually, or and also you have iodine. That's another example. You have iodine and you also have ammonium chloride. All right, so we go on to question number 23. This question says, by means of filtration, one component can be obtained pure from an aqueous mixture of sodium chloride and A, you have potassium nitrate, B, you have sand, C, you have lead nitrate, D, you have sugar, glucose, and E, you have starch. Now, in this case, which of these option would you think you can let's look at the question again now. By means of filtration, one component can be obtained pure from an aqueous mixture of sodium chloride and what else? Now, if you have all of this, for example, potassium nitrate and sodium chloride, if you mix this together, there might be a reaction taking place, and it will be difficult again to separate them. So this will be difficult. If you have sand, the next option, sand would not mix with sodium chloride. I mean, even if they do, there won't be any reaction here. And if you dissolve them in water, you can dissolve. If you add water to this mixture, you can dissolve the sodium chloride and filter. Then you get your sodium chloride going out with the water while you have your sand. Because sand is insoluble in water and it will not pass through the pores of the filter paper. So you can have the sand behind while the sodium chloride would have gone with the water by passing through the pores of the filter paper. So that's the B would be the right answer to this question. But let me know what you think in the comment section. Question 24. So it says methanoic acid mixes with water in all proportions and has about the same boiling point as water. Which of the following method would you adopt to obtain pure water from a mixture of sand, water, and methanoic acid? Okay, so we have option A, fractional distillation, B, filtration followed by distillation, C, neutralization with sodium hydroxide followed by distillation, D, you have neutralization with sodium hydroxide followed by filtration, and E, you have esterification with ethanol followed by distillation. So what is going on here? The answer here would be B. So filtration will separate the sand from we separate the sand from the methanoic acid and water, right? And afterwards, you can now subject the mixture to distillation. So distillation will be used to separate the water from the methanoic acid, because both of them would have different boiling point. Remember that distillation is used to separate two different solvents that have different boiling points. Okay, so it can be used to separate solvent from a mixture. But in a case where you have two, that would be, you will take advantage of their differences in boiling point. So that is the answer to this question. Question number 25. One of the following technique can be used to show that a chlorophyll pigment is a mixture of chemical compound and not a single colored compound. So what method do you use to separate colored substances? Chromatography. Remember that? And this is a method that is based on the rate of movement over an absorbent paper. So chromatography is used to separate colored substances. The answer to this will be E. Let's go on to question 26. In the attempt to remove sugar from a beaker containing a quantity of sand and sugar, 2 molar ammonium chloride solution was accidentally added instead of water. Which of the following method could be used to remove the ammonium chloride from the mixture? Remember again, filtration is first used to separate, in this case, so let's look at the option first. Fractional, this should be fractional distillation, crystallization, filtration followed by evaporation, evaporation followed by sublimation, filtration followed by sublimation. Now, take this very seriously. Sublimation will be important because you have ammonium chloride. Remember that ammonium chloride is one compound that sublimes. Right. So, but what do you do first before sublimation? So we have our answer between D and E. But which of them? So, in an attempt to remove sugar from a beaker containing quantity of sand, a quantity of sand and sugar, remember that if you have mistakenly added 2 molar um, ammonium chloride solution instead of water, what will happen is filtration will have to be used first to separate the dissolved sugar from the sand, because the sugar will definitely dissolve in the 2 molar ammonium chloride. Once the sugar dissolves, then you can filter. I mean, the sugar dissolve, you can filter. Then after filtering, you can then subject the remaining mixture to sublimation, which will be used to then remove the ammonium chloride from the sand. So our answer then would be filtration followed by sublimation. E. Question 27. Which of the following compound and element would sublime on exposure to the atmosphere? You have ice, sulfur, phosphorus, iodine, and potassium iodide. So the answer to this will be iodine, D. Question 28. A mixture of common salt, ammonium chloride, barium sulfate can be separated by, so you have again ammonium chloride. So you should expect sublimation as one of the options. So now in this case, we have sublimation as option A. In option A, we have sublimation as option B, sublimation in option C. So our answer will be between these three. But now let us trace it very well. You know, sublimation would remove the ammonium chloride. Then if you add water, the water would dissolve the sodium chloride. Right. And after that, you can then remove by filtration. So sublimation will start first, followed by filtration. So the answer to this would then be C. Question number 29. Sodium chloride may be obtained from brine by what process? Okay, so the first thing first is, what is brine? Brine is seawater, which contains a high degree of sodium chloride. So if you have seawater, which contains a high degree of sodium chloride in water, how do you obtain pure sodium chloride? Of course, this will be by evaporation to dryness. Evaporation to dryness would remove the water and the sodium chloride will be left. Now let's take question 30. When kerosene fraction from petroleum is heated at high temperature, a lower boiling liquid is obtained. This process is known as, of course, kerosene and other substances of petroleum have relatively close boiling point. So that process would be fractional distillation. And the answer to this will be option E. Now question 31. It says the iron 3 oxide impurity in bauxite can be removed by. Now this is taking us to extraction of metals. Now that this is one of the everyday application question. Remember the syllabus says one of the objectives of the syllabus is to apply what you have learned in every topic to everyday application. Of course, iron 3 oxide impurity in bauxite do not react with or in alkali. So if you bear that in mind, let's look at the options first. It says fractional crystallization in acid solution, dissolution in sodium hydroxide and filtration, extraction with concentrated ammonia and precipitation, D. Electrolysis of molten mixture. So how do you remove iron 3 oxide impurity? So iron 3 oxide impurity do not react with or in the alkali solution. So they can be filtered off. So basically, if you dissolve them in sodium hydroxide, you can then filter off. Otherwise, if you crystallize them in acid solution, there will be a reaction. This is not an option. Extraction with concentrated ammonia. Concentrated ammonia might also be reactive. So these two options would not work. But because um, iron 3 oxide will not react in sodium hydroxide, then you can dissolve in this and then filter. Question number 32. It says a brand of ink containing cobalt 2, copper 2, and iron 2 ions can be separated into its various components by. Now, this is used to a brand of ink containing all of this. Remember, ink is a dye, right? Which method is usually used to separate dye? That would be chromatography. Anything that involves separation of colored compound, usually colored substances, usually chromatography is applied. Let me know what you think in the comment for this question. And we go on to question 33. Question 33, you have this diagram. You have ammonium chloride at this point. You have ammonium chloride at this solid ammonium chloride at this point here, and you have ammonium chloride at this point, and you're applying heat to the solid. So the whatever ammonium chloride you have here will be gas because there is a process of sublimation taking place between this point to this point. So in the experiment, ammonium chloride crystal deposit on the walls of the tube is as a result of what process? Sublimation. B. Option C. Then question 34. Which of the following can be obtained by fractional distillation? You have nitrogen from liquid air. You have sodium chloride from seawater. You have iodine from a solution of iodine in carbon tetrachloride. You have sulfur from a solution of sulfur in carbon disulfide. Of course, I would, in this case, the right answer to the question would be option A, because air is a mixture of gases, and in this mixture, you have other constituents like hydrogen. You have like oxygen. Let's begin with oxygen. You have nitrogen, and you also have copper. Carbon dioxide. Primarily, of course, there are other inert gases in the mixture of air, in air, which is a mixture of gases. Now, if you look at the boiling point of all of this, they have close boiling point. For example, um, oxygen has a boiling point of minus 183 degrees Celsius, minus 183. And nitrogen has minus 196 degrees Celsius. You have carbon dioxide has minus 79 degrees Celsius. So you can see that they have close boiling point. So they can be separated by fractional distillation. So the answer to that question will be A. Question 35. A mixture of sand, ammonium chloride, and sodium chloride is best separated by. Now this is becoming another repeated question. Sometimes it becomes boring when questions are repeated over and over. Of course, when you have the fact that you have ammonium chloride in a mixture of sand, ammonium chloride, and sodium chloride. So the first thing is to um, to carry out sublimation, apply a little bit of heat that will make this ammonium chloride to escape away as gas. Then you'll be left with sodium chloride, sand and sodium chloride. Then you can dissolve in water and then filter. So this is the answer A. Question 36, you have chromatography is used to separate components of mixtures which differ in their rates of migration. Of course, you remember that chromatography, um, you have the component moving at different rate over an adsorbent medium. For example, in paper chromatography, you have this paper here, which is the chromatography paper, and you have different mixture moving up at different rates. So their rate of movement over this absorbent medium are different, and that is the principle for separation of mixtures using chromatography. So the answer will be B. Question number 37. It says, so you have this solubility curve here between two different mixtures P and Q. In the diagram, the mixture of two solid P and Q can be separated by, Now, because they're taking advantage of their difference in solubility. So in distillation, you're taking advantage of their differences in boiling point. Sorry. So, but in solubility, you're taking advantage. I mean, crystallization, you'll be taking advantage of their differences in solubility. I hope that is clear. Now, when you have um, two or more mixture that have close difference in solubility, then you'll be looking at the process of fractional crystallization. So that's the answer to this question then would be option D. Let me know what you think in the comment section. Question 38. Sieving is a technique that is used to separate solid particles of small size, large size, different sizes, same size. What do you think? Of course, different sizes, the smaller ones will move through the pores while the bigger ones will stay behind. So the right answer will be C. Question 39. The filter in a cigarette reduces the nicotine content by what process? So we have adsorption, we have absorption, we have burning, we have evaporation. So the answer to this question is A, and that will take a lot of explanation. So in the case of the word adsorption is the addition of molecules. It could be molecules of gas, molecules of liquid, or dissolved solid to a surface. So remember, when you have chromatography, you're talking about the word adsorption or adsorbent medium. So the chromatography paper, for example, is an adsorbent medium. So when a molecule comes to stay on this surface of this chromatographic paper, that is an example of adsorption. All right. So that adherence of molecules of liquid, gas, or dissolved solid to that surface, the process is adsorption. Now, what happens is that this process creates a film of the of this substance that is absorbed, which is called the absorbate. So the molecule or the atom being accumulated on this surface would be called the absorbate. All right. So it's quite different from what you have in absorption. So in absorption, what is happening is that the fluid particle will be dissolved by liquid or solid. That is absorption. That's a different thing. Or where you have a particle permeating a membrane, that will be absorption. But in the case of adsorption, they stay on they remain accumulated on the absorption surface. So that's the answer to this question is adsorption. And question number 40. Sugar is separated from its impurity by distillation, evaporation, precipitation, or crystallization. How do you separate the impurity of sugar? Of course, that will also be other impurity will have different value of solubility, and that will be crystallization. Um, for you to appreciate this question, you must understand the different steps that are involved in the purification of sugar. So it begins with the extraction of the cane juice. Okay, when you when you extract the juice from the sugar cane, and then you begin to concentrate the juice to a syrup by the process of evaporation, and then the crystallization of the sugar from the syrup, and finally you have the separation and dryness of the crystal. That is the process of crystallization. So, question 41. The order in which a mixture of sand, ammonium chloride, and sodium chloride can be separated is, again, you have ammonium chloride. Once you have ammonium chloride, you have sand and you have sodium chloride. First thing first, sublimation. We take out the ammonium chloride, so you have sublimation. What then do? You dissolve in water, then you filter. When you filter, you have the sand, and then you have the water and the sodium chloride will go. When you evaporate the water and sodium chloride to dryness, then you can remove the water and leave the sodium chloride. So you have this step: sublimation, dissolution, filtration, and evaporation. The first option. Now let's go to question 42. A mixture of petrol and water can be separated through the use of filter paper, use of separating funnel, centrifugation, distillation. Of course, this will be the use of separating funnel. Separating funnel is used to separate two immiscible liquid. Two liquid that do not mix. You use a separating funnel. Question number 43. Chromatography obtained from green leaves of plant can be shown to compose of more than one colored component by the technique of chromatography. Option C. A mixture of sugar, sulfur can be separated by what method? A mixture of sugar and sulfur. Question 44. So you have dissolution in water, evaporation and filtration. Filtration, evaporation and dissolution in water. Dissolution in water, filtration and evaporation. Evaporation, dissolution of water and filtration. What is dissolving in this case? What would dissolve? If you have a mixture of sugar and sulfur, if you dissolve in water, the sugar will dissolve, the sulfur will not. Then if you filter, the sugar will go with the water, the sulfur will remain. Then if you evaporate to dryness, the water will go and the sugar will remain. So in this order, dissolution in water first, followed by filtration, followed by evaporation. Option C. Question 45. Which of the following is an example of a mixture? You have blood, sand, washing soda, common salt. Which of the following is a mixture? Of course, when you have blood, you have within your blood you have blood cells. If you centrifuge your blood serum or your blood plasma, you're going to have the blood cells going to settle at the bottom while you have a clear solution. So if you take our blood and put in a tube like this, and then you put in a centrifuge, let's say this is a cup, and then you spin. After some time, you have the blood cell going to settle at the bottom, and you have your blood serum staying at the top. You have the cell here. So that tells you that blood is a mixture. Sand, of course, is a compound. Washing soda is a compound. Common salt is a compound. Question number 46. The principle of colon chromatography is based on the ability of the constituent to dissolve in each other in the colon, react with the solvent in the colon, react with each other in the colon, move at different speed in the colon, move at different speed. Remember, chromatography is based on the principle of differences in rate of movement over an adsorbent medium. And question 47, this is where we're going to stop. Which of the following method can be used to obtain pure water from a mixture of sand, water, methanoic acid? Now this is interesting. All right, this is interesting. Question number 47. Of course, there will be distillation here because water and methanoic acid will have close um, close boiling point. But then if you have sand as part of the component, so you first have to filter to remove your sand and then subject the rest these two solvent into to distillation to remove them at different boiling point. So the answer to this will be filtration. With that, we have come to the end of the question. There are still a lot of questions in the textbook, explicit biology, and of course, you can also take questions, as many questions you can lay your hand on in the in the in the past question and answer booklet. So if you have any question, if you have any concern, don't forget to leave a comment for me and I'll respond to your concerns. So in the next video, I will do another video that would address the second topic, and at this point we'll be moving into calculation in chemistry. So without further ado, I'll stop the video here. I'll see you in the next video. Thank you for your time. Bye bye.